In the 1980s, the apron of an airport would have looked nothing like that, what we are used to today. The plane market was actually quite diverse back then. You would see the McDonnell Douglas DC-8, the MD-80, the Concorde, the Airbus A300, the Boeing's classic 737, Lockheed's TriStar, or even Russia's Konkordsky, the FFFTE-144. While those planes might not have a lot in common, there is one key element they share: the yoke. My name is Flo, welcome to Foredeck. It all started out way back in 1919 when Junkers developed their F-13, which later became so popular that Brazil operated their F-13 way into the 50s. One thing that undoubtedly has not changed is the way we manipulate the primary flight controls of the aircraft. It has more or less remained the same until March 1984 when Airbus released their A320 family. Design of the aircraft was commenced in June of 1977 when British Aerospace, Aerospace Yale, Dornier and Fokker formed a new joint European transport program. In February of 1981, the project was designated as Airbus A320, and initial designs shown to the public did actually not look so radical. But then flight deck designs were first shown to the public. The new sidestick was a revolutionary design change. Not only could the pilots now enjoy their meals on a small table right in front of their seats put in place instead of the yoke, but also a wide range of other operational and piloting advantages like auto trim or flight envelope projection could be expected by the new flight controller. Bernhard Ziegler, son of Airbus's founder Henry Ziegler, was the most influential figure in developing the cockpit design, the fly-by-wire control system and flight envelope protection system for the modern Airbus airliners. Also, the new flight deck design gave Airbus a little bit of an edge over Boeing, as Airbus's design was way more exciting and unique. It's not like this design has never been seen before. The original idea dates back as early as 1956, when initial flight tests were made on a F-102A in order to test a newly developed sidestick controller. It later became standard on the F-16s of the 1980s. But the new sidestick was not the only thing that changed with the introduction of what will become Boeing's 737's biggest competitor. In fact, the sidestick is only the tip of the iceberg if you want. With the Airbus A320 being the first airliner to have a digital fly-by-wire flight control system, the whole philosophy of how a plane is controlled and the authority of the pilots has changed. Tested early in the Airbus's first aircraft, the A300, this new system was a unique experience for many pilots. For Roger Bettiel, then Airbus president, introducing fly-by-wire with flight envelope protection was one of the most difficult decisions he had ever made, explaining either we were going to be the first with new technologies or we could not expect to be in the market. Fly-by-wire together with the flight envelope protection allows the system to prevent the pilot of an aircraft from making control commands that would force the aircraft to exceed its structural and aerodynamic operating limits. And these include protection from high angle of attack, pitch attitude, load factor, bank angle and high speed protection. So if a pilot were to make an input on one of its side sticks, a flight control computer would analyze the input together with other parameters like indicated airspeed, altitude, and the aircraft's configuration. And only if the input is within the limits of the envelope will the aircraft execute the maneuver. The computer calculating the output and deciding on whether or not to perform the input of the pilot only takes a few milliseconds. So what happens when the captain wants to go to the left and the first officer wants to go to the right? In a conventionally controlled airplane with push rods and a yoke, both flight controls are physically interconnected, so one pilot could overpower the other pilot, provided he would have ample enough biceps. And this is where it gets interesting on the Airbus family aircraft. Designers have elected not to interconnect the side sticks physically. Side sticks work independently from one another. So whatever input one pilot might give, the other pilot has no idea about his input on the controls because he physically cannot see the other side stick. And when an input is given on both side sticks simultaneously, the system adds the signals of both pilots algebraically. So if one pilot's input is full left and the other pilot's input is full right, the aircraft will stay wings level. If both pilots would give an input for the ailerons to deflect up to 50%, the system would add both inputs together, resulting in 100% aileron deflection. The total output is limited to the signal that would result from the maximum deflection of a single side stick. The same principle applies to the pitch axis. And the idea behind this philosophy is that in a conventionally controlled airplane, both pilots' control forces would also add up. If both pilots push the ailerons to the left with a certain control force, a bigger deflection would be the result compared to only one pilot on the yoke. Each side stick has a priority button located on the side stick. During normal operation, this button is used to disconnect the autopilot or to take over priority from the autopilot. This button can also be used along with the phrase "I have control" to indicate control takeover from the other pilot. A pilot can cancel out the input of the other side stick. An oral signal, priority left or right, will appear together with a red light on the cancelled side and a green light for whoever pushed the priority button. The priority push button, when pressed, gives side stick control to the pilot who pushed it last. If you keep holding the button and past 40 seconds, the other side stick deactivates. It can then be activated again by pressing the priority push button on the other side stick. Developing such a control system is no easy task, with each manufacturer having a different approach to flight control laws. Airbus had, with its A320 families in the 1980s, developed an aircraft way ahead of its time. For an airplane manufacturer to come out with a new aircraft today, it isn't very likely to have a conventional flight control system, especially seen with the limitations of the 737 MCAS, where a fly-by-wire system would have definitely made it easier to implement a control input on the horizontal stabilizer when a critical angle of attack is reached. That being said, the Airbus fly-by-wire system has its limitations, and it's far from perfect, as seen in the accident involving an A330 over the Atlantic. Air Force Flight 447 stalled at cruising altitude due to unreliable airspeed and subsequent confusion by the crew, which led to a total loss. And both pilots in control at the time inputted different commands to their side sticks simultaneously. Because of that, the pilot flying's fatal nose-up input, which subsequently led to the crash, might have been unnoticed by the pilot not flying, as controls give little visual feedback and no sensory or tactile feedback to the second pilot. You might ask yourself why Airbus, of course fully aware of their system's limitations, is not willing to change or adapt their system to make it interconnected with one another. Now that would be a major design change to their flight tech, requiring a whole different certification for the new type, crew training, and Airbus is losing commonality across their types. Airbus's huge selling point is their common type rating for their A319, A320 and A321, including their new engine variants. If the airplanes lose similarities with one another, it will be more costly and timely to retrain the pilots. And this commonality is one of the reasons why the 737 MAX 8, as the current production airliner, still lacks an ICAS to avoid losing similarities with previous types, but that's a whole different story. And for that reason, we will probably have to stick to the old side stick for some more time. Now that being said, looking at the safety record and possible issues involving their design, there is no apparent reason why Airbus might elect to revisit its side stick philosophy. They've built over 13,000 airframes with their side stick design, and there is one major accident where their design might have been an issue. But the leading problem with Air France 447 was the false recovery from the stall. It's proven to be an excellent design with no significant drawbacks. But there still might be the superior and maybe even perfect flight control design. The Gulfstream G500 and G600 both uses active side sticks, which are electronically linked with one another. This system mitigates any significant drawbacks that the Airbus side stick might have. Because they are linked, it is easy to see what the autopilot, or more importantly, the autopilot does. There is no issue with dual input, as there can only be one input. And the question of who is controlling the plane becomes much clearer and does not have to be emphasized with green or red lights as seen in the Airbus. As seen in the past, most of the new technology used in business jets like the Gulfstream will sooner or later be implemented in the commercial airliners as well. corporate aviation serves as a bit of a test bed for newly developed technology. The new Gulfstream, together with other airplanes like the KC-390, are equipped with BAE Systems active inceptor sidesticks. They have been developing those active sidesticks for 25 years now. Active sidesticks aren't new, but they had never been implemented in the commercial aviation sector before. The benefit of the active sidesticks is not just seeing them both move together, but also tactile cueing, which electronically adds feel to the sidestick, also called artificial feel unit. As the pilot rolls or pitches the jet, he will feel a discrete change in feedback gradient. These so-called soft tops, where pilot operating the stick starts to feel a change in resistance, are subtle and change the stick's feel in real time. As the sidestick provides tactile cueing or feel, it can tell the pilot intuitively through the sidesticks that the jet operates close to the performance limits without the pilot ever looking at the PFD. In an emergency where most of the electrical power fails, the sidestick can still be operated as a conventional passive sidestick. And this new active sidestick design may be found in the next generation airliners of Airbus and even Boeing. And if so, it will probably take a few more years for the plane makers to utilize the active sidestick and for airlines to retrain their pilots, as current passive sidestick technology has proven itself over the last 35 years with an excellent safety record. Until the next one, stay safe.